from? Show me the Q2E. Tell me products. First, you know, show me the beauty. What I said, reductive analysis. What is the simple logic? Break. Go. E. Come on, tell me. What will come? Double bond. Huh? See, double bond breaking. Double bond means this double bond I am not breaking. Here it is breaking. Here double bond is there, here double bond is there. So with the double bond only what is go I am telling. Go means what? You are breaking middle, one side oxygen, another side oxygen. Tell me, what will form like this here? Just use, see, if I am writing line formula, then you have to understand. No, sir, I will write total non-carbonate. No, sir, write what? You want to write that one like this will form. What now? CH3, CH3, double bond, C, CH3, H. 1, 2, 3, 4. 2 will then due to use. Now you are breaking here. Means what will come? CH3, CH3, double bond O plus E. CH3, C, H, double bond O. I said now O, go. This only O. I am telling here the double bond. Here the preparation of 180 ketones, you know this one again. Where will study? Preparation of 180 ketones, you will study this problem. Very, very important. So this is acetaldehyde. Ethanol. Sinana. Ethanol. AL. Aldehyde. This is propanone. Propane to no need to tell. Only one more. That one acetone. General name. Propanone is acetone. Are you getting what I'm saying? Like this. Understand? Hello. Why am I telling like this? Sometimes reverse problem they will ask. They will give product. They will ask react. For example, see, I am writing here like this. Reductive ozonolysis. What is the reagent? CCl4 and ZnH2O. According to situation. Then what is A? Like this. You see, first what you have to do. Acetone means this one. Here also double bond is in that. Same side you write. Same side means like this and understood? What you have to do? You break this one oxygen and simple. Double bond is bring or remove, extend the double bond. That's all. Then what is the compound? Tell me. 2,3 dimethyl butadiene. I bet. 2,3 dimethyl butadiene. Reverse problem understood. What you have to make? Double bond is break. O is remove. Extend R. Product over. Any doubt? here. What are you making? Here you see, actually this is real. Whatever thing, double bond break. Wherever double bond, that many double bond you have to break. And it should be attached double bond group. Means see what I am writing. For understanding I am writing. Double bond group, double bond group. Well, this is real. One double bond only you have to break. Okay. See here. If it is like this, here will break, here will break. Let it go. Oh, what's the name? This one? 1, 2, 3, 4, 5, 6. And here. Here we go. Okay. There is type of question they are asking NEET examination. Difficult means they will ask I type name. Reverse problem they will ask. What is that? Like this. Understand? Here. Now see two compounds. Here only one compound. Sir, up to now two compounds are forming, sir. Why? That only one double bond. Not real. That is two compounds. One double bond means two compounds. In ring, one double bond only one compound. Here two double bond two compounds. In ring. For example, you see here. If I am taking like this. If I am doing reductive also, what? Let me pass. How many compounds will form, you know? No, no. This is one compound. This is one compound. This is one compound. Three only. This is two now. What is this? Carbon here. Double bond over this one. Fragment completed. Now here like this is there. This is you understood that one. Next time. This is forward. Now what it is? Huh? Like this should be done. This one. No, no. It is form product. The product. Again, product will do product analysis. I'm telling there the product. For simple and for understanding why three compounds I'm telling logic. You said four, no. Sir, one double one, two na, two double one, four. Don't tell like that. Don't tell like that. Why? Here bond breaking oxygen oxygen attached. Here one compound removed. Here one compound removed. But this is attached only na. Yes, sir. What it is? Ketone is there, aldehyde is there. Which is major? Then one, two, three. Then what is the name? Propane. Two also. Propane. He removed one all. Completed question. Understand what I'm getting? Like this. Now see for example, you take benzene, do reductive ozonolysis. Come on, tell me. Take benzene and do reductive ozonolysis. Benzene. Benzene is if I write here the no compound, anything is safe. What is the compound? What I find again. How many compounds are found in? Nana, you see here. Total this one is one compound, right? Total this one is one compound, right? This one is one compound, right? This one is one compound. Three only. For understanding, I am writing here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. What will form? You see here I am writing. Reductive ozonolysis. I am writing C here. This I am taking. A double bond. Sorry. What is that? Double bond O hydrogen double bond O hydrogen. This is one fragment. Here also same fragment. Correct? Like this, how many will form? Three will form. What is this? You know, name? Diaphragm. Diaphragm. Understood? Why this one also like that only? C. CH double bond O. CH double bond O. They are the same. With three modes of diaphragm it is formed. Benzene or ozonolysis, three modes of diaphragm will form. Then a simple logic. Double bond break. Double bond break means only don't break. Oxygen oxygen. Break oxygen question attention. Let's see. Understood right here? One is formaldehyde, another one is ethanol. Here what will come? How many compounds will come? This is a ring. Rightly here also break up. One compound only. Normally open chain double bond two compounds. Breaking oxygen. But here it is adjusted. Here ketone will come, here aldehyde will come. Then you understood this one already I am given. Here what will come? Very important. What will come? Here. First, two moles of formaldehyde. This formaldehyde, this is formaldehyde. And this one, glass one means here double bond O, here double bond O. Means what? For understanding I am telling. Double bond OH, double bond OH. Glass one like that. Simple because double bond breaking oxygen. Go. For understanding I am telling. Wherever formaldehyde is forming, there is CH2 double bond fragmenting. Wherever formaldehyde is forming, this is formaldehyde. This one same, don't confuse. Wherever formaldehyde forming, this fragment should be there. So formaldehyde forming, two fragments are there. Like that, logic. Understood? Can I do? Next, oxidative ozenolysis. Already I am giving this one. Directly by using this one. Either if you use O3CCl2H2O or hydrocarbons, H2 or hydrocarbons, you can use anything. Ozenolysis followed by oxidation. Oxidating agents like KMnO4, like that also, directly. What I said at the time, tell me again. Three fragments will be there. In the three fragment, this fragment converted to CO2 H2O. The reason is here oxygen forming. This is unstable due to that one. Again, oxygen. So water molecule remove, CO2 will form. From oxidating agent. Because reductive ozenolysis formaldehyde forming, formaldehyde only will be there. Formaldehyde again not converting into CO2 H2O in reductive ozenolysis. But here Formaldehyde forming, again that will convert it to CO2H2O because came about strong oxidation. Like, and another thing, if this fragment is there, this will become what, Nana? Acid. CH converted to acid. And this fragment is there. This is forming what, Nana? Ketone will form. This fragment is ketone will. Like that. Three types of fragments double bond oxidative osmosis. Nothing. So like that, here if you see oxidative osmosis. This side CO2H2O. See. That's what it is. Open coming. But this is again their H is there. I said which type of fragment this one? RCH double one fragment. RCOH will form. See, RCOH is formed. This fragment RCOH form. Oxidative osmosis. So what I want to tell you, normally you do osmosis. Reductive osmosis you do. Wherever formaldehyde forming, that is converted into CO2H2. Okay? Wherever aldehyde forming, that will convert into acid. Wherever ketone forming, ketone only. In oxidative analysis, formaldehyde forming na convert into CO2H2O, aldehyde forming na that will make into acid, and it will be CHO, that is COH will be made like that. Wherever ketone forming, ketone only keep. Ketone further will not occur. Like logic and they given this one in civil textbook not written. But we will study preparation of acids, preparation of aldehydes, preparation of ketones. Both we will study. Understand what I said? Just remember that. Here also. Now see tell me oxidative osmosis. What will form this one? Acetic acid, CO2H2O. First thing. Easy, right? CH3, CH. Which type of fragment? RCH double bond fragment. Normally, reductive osmosis, this is ethanaldehyde. This is formaldehyde. Ethanaldehyde becomes ethanoic acid. Formaldehyde becomes CO2H2. Oxidative osmosis. Now here, this ketone, this is ketone, and it becomes COH. Like, yes, for understanding. Any doubt? Okay. Now, oxidative osmosis to do what? Tell me. Take more time. Tell me what oxidative osmosis. Oxidative osmosis what will form? What is that acid name? Now, normal reductive osmosis what will form then? How many? Yes, sir. Now, formaldehyde becomes what? Oxidative osmosis. CO2H2. How many will form now? 2CO, 2H2. Completed. Middle. Which acid? Acetic acid. 2-carbon is acetic acid. Actual reductive osmosis what will form, you know? Glycol will form. Glycol means what? What is glycol? You keep pen on paper, you will get. Without keeping pen on paper, you will not get, you will confuse. That much brain not is up to now. Practice, you will get that brain. Why am I saying CH2O, double bond O? I said na, wherever this fragment is there, this is becoming CO2H2O. Either you remember that one. Wherever this fragment is, it becomes CO2H2O. You understood this one. But here actually, CH becomes what? COOH. CH becomes what? COOH. What is this? Oxalic acid. You said ethanoic acid. Right. That's it. understanding I am taking. Sir, this will become reductive ozonolysis like this, sir. Glyazol. Yes. CH double bond becomes what? COOH. CH double COOH. That means that's organic acid. And that's what it is. Extra points I am telling. Actual oxidative ozonolysis is not there in this test book for this syllabus. I ask. Why? Where it is useful? Very important. Next, putting polymerization. Very simple, you know. Polymerization is simplest test of what they can use. Polymerization. You are familiar with the polythene bags, polythene sheets. Polythene is obtained by the combination of large number of ethene molecules at high temperature, high pressure, and in the presence of catalyst. What they will do? They will take polymer means many compounds combined exist as one unit. That is polymer. So if you take that one alkenes, different types of alkenes. At high temperature pressure in the presence of catalytic send, it will combine and it will form polymer. So this reaction is a polymerization. So the large molecule that obtained are called polymers. Monomer means single compound. So for polythene, what is the monomer? Ethene is the monomer. Polythene, poly plus ethene. Ethene is the monomer. So n number of monomer, you see the given. N number of ethene at high temperature pressure catalyst. What is forming? What you have to do? You know, simple logic are here. By giving this one, what is the monomer? Like in the last question. That means what you have to do here? Bond here make, here bond here make, double bond you can get that one. You see this one? This is polypropylene. Here double bond what I am making here double bond I am making. Then what it will become? So by giving one polymer, they lost what is the monomer? Polypropylene. Polystyrene. Polystyrene. What is polystyrene? Is it polystyrene? Means instead of this one, what will be there? Benzyl. That polystyrene. This is called styrene. General name styrene. What product is ethylene? Styrene. Like that. So polymers are used for the manufacture of plastic bags, steel bottles, refrigerator, dishes, toys, pipes, radio, TV, tablets. Extra polypropylene is used for the manufacture of milk crates, plastic buckets, and other molded articles. Though these materials have now become common, excessive use of polythene and polypropylene is a matter of great concern for all of us. See, we will keep that our candidates like that will go. But house will come and eat cancer will come house. They will die. But I don't know, it will eat along with the plastic bags. Nowadays, the plastic bags and microns, this only you have to use. In very strictly they are following. And I think 3 years, 4 years back they followed strictly because of correction. Understood? I know. Okay, right. So, based on this one question, actually, one chapter is there, the polymers chapter remote. Sorry, chapter that they remote. At that time, you study Teflon. What is Teflon? You know, you study the metric syllabus. Tetrafluoroethylene. Teflon. you are making a dosha or that Teflon content, it will not burn easy. Teflon content. Along with Teflon also will eat. That is not good for health. Okay. Now put in all kinds. So preparation property is completed. Now alkynes in general form of ClH2n minus 2. Alkynes. They are unsaturated hydrocarbons. They contain at least one double bond between two carbon atoms. The number of hydrogen atoms is still less in alkynes as compared to alkenes. So general formula coming like this. And the first stable member of alkyne series is ethylene. Methane is there. Methane not there. Like methyl not there. First member is ethylene. First member of alkene also ethene. That only we are calling property known as acetylene. Very important thing. Ethylene is ethene. Ethylene is general THYNE. Acetylene is ethyl. Acetylene is used for the welding purpose in the form of oxyacetylene clay obtained by mixing. Nowadays, anyone is coming welding and like that. Nowadays, we are using plastic buckets. It is very less weight. Comfortability is there, no doubt at all. In olden days, we will use all steel buckets or iron buckets. It is there iron bucket in the home. In our home, no, not there. Did you see any time iron buckets? Huh? You observed that? At the time that fellows will come and they can welding. Oxyacetylene flame is important. High energy. Alkanes are starting material for the large number of organic compounds, hence it is interesting to study this class of organic compounds. See here I want to tell one point overall. Here if I am asking one question like this, you see, if you want to make okay, as a chemist, you did now so many reactions. How will you convert them? I get it. You come reverse. Up to now, anytime benzene you prepare. Now, alkenes completed. In any manner here, anytime you prepare benzene. What is aromatization? I am telling this one. I am telling every day how to reverse. Then only come to know. Otherwise, you forget. How do you do aromatization? NHA to take. Now the question is, if it make here NHA 1, 2, 3, 4, 5, 6. What is this one? Aromatization CR2O3, V2O5, MO2O3, high temperature, high pressure. You will get this. You know that, understand. But to make this one, first what you will do? If I use 4 grams in this, then I can prepare an exam. You know, 4 grams. Which type of alkane you want to prepare? That type of alkane. That is last one R2 Cl is there, RCl is there like this. Here if you take C5 H pentyl chloride, then directly we can get NX. Or sir, I want to do normally Wood reaction you have. Wood reaction if you do here. What do you do Wood reaction? Na dry ether. If you use ethane will form. Again if you use Na dry ether, sorry. Again Cl2 H nu if you use, then again would you reaction if you do butane is formed. From butane how will you prepare? You see here, if I am making, for example, what is this? Controlled oxidation. Ethane convert ethanoic acid like that also can make. From that, if you take CH3, CH2, COOH, like that, for example, for understanding and play. Just for idea, okay, how will you make that NHZN? Then, if you use the post electrolysis, what will form? CH2, COH. If you use post electrolysis, here dot will form another dot combine and exam will aromatic ions. Just for understanding and reading. Conversion. All these conversions, what will happen? Will revise. Okay. We'll work at general I know. Every day you revise reaction. Then easy to understand. Okay. Now see here. Nomenclature of isomerism, you know. Acetylene, common name, methyl acetylene, ethyl acetylene, dimethyl acetylene, like this actually. But you know what is isoprene easily without the know here. Write the structures of different isomers corresponding to 5 members of the alkyne series. Fifth member of the alkyne series, different isomers write. So here also, what will form structural isomerism is possible. In that position is possible, chain is possible, definitely. But ethyl does not show any isomerism. Propyl, see, propyl will show ring chain isomerism. Ring chain isomerism or not. Propyl will show ring chain isomerism or not. Question. How much? Then what it is? Tell me. Propyl ring chain isomerism show me. Propyl. Red bomb. Propyl ring chain isomerism show me. Now three carbons are there now. Ring is possible or not? See. See how it is possible. Sir, this is the propyl, sir. Ring is possible, sir. You make double one. These two isomers. Check it. How much do you? Two. Don't tell. Sir, these two isomers. Du1, Du2. How it will be same formula? Logic. Propyl will show ring chain isomer. Yes. Like this. But the ring of the answer. Understood? Any doubt? Now see. one question. Fifth member of propyl is hexane. 1, 2, 3, 4, 5, 6. That hexane, how many types of isomethylene are? Hex 1, 9, hex 2, and hex 3. Then one fragment will be attached. Here we can get 3 methyl pent 1, 9, 4 methyl pent 1, 9, 4 methyl pent 2, 9. And finally, 3 comma 3 dimethyl butane. How many polymers are coming? A, B, C, D, E, F, G. 7 isomers are found. In that position, the chain isomers shown by different pace. Now we can show these three are positional isomers. These two are positional isomers. Even these are also positional isomers. 4 methyl pent 2, 4 methyl pent 1, 9. But 3 methyl pent 1, 9 is also positional isomer. With this chain isomer. But you see this one, due to 1, 9. When compared to this one, all chain isomers. With this, like that. Okay. So structure of triple bond. Triple bond structure, like alkene, what I am telling, like this will tell. For example, see this one. Here, triple bond structure we are getting. So what is the hybridization here? Sp. Is also Sp. Which means you have to understand that one. Sp means two Sp hybrid orbitals we can get. It means this is one Sp, this is one Sp for this carbon. Here also, this is one Sp, this is one Sp for this carbon. That means one p orbital is there, one p orbital is there here. Two p orbitals are there like this, which are not hybridized because in carbon 2s2, 2p2 is there now. There 2s1, 2px1, 2py1, 2pz1, like the sp hybridized, it is hybridized. But these are not hybridized now. Here one electron, bond formation. Here one electron, bond formation. Up and down, don't confuse. 5 bonds. But here, this is sp, this is sp. This is sp, this is sp. With this, one hydrogen is there, that is oneness of hydrogen. Oneness of hydrogen. Oneness of that. So you have to understand that one. Sp sigma bond is there. Sp oneness sigma bonds are 2. 5 bonds how many? 2. 5 bonds generally will form with the pure orbitals, which is not hybridized. Like that. Okay. So it is linear. These two carbons are linear form. Any doubt? 5 bonds will be up and down, sandwich there. Will be there. So now preparation, they given preparation only two preparations according to our series textbook. What is that? First one, you write. Okay. Before that one, you should know what is the triple bond length. Triple bond length, how much they give? 120 picometer. Double bond 133, single bond 154. So when bond number increases, bond length decreases, bond energy increases. This bond energy is almost 823 kilojoule. Understood? Clear? So electron flow between two carbon atoms is cylindrically symmetrical above the internuclear axis. Symmetrical. The return is a linear molecule. Cylindrically symmetrical. Okay, now you see preparation from calcium carbide, right? Calcium carbide. How we are breathing? On industrial scale, ethane is prepared by treatmenting with calcium carbide with water. But that calcium carbonate is prepared by heating quicklime with coke. Quicklime can be obtained by heating limestone. So, I am taking limestone, calcium carbonate. Heating, what is forming on a quicklime? Quicklime means CaO plus CO2 here, mixed CO2. Then the CaO plus carbon, quicklime plus carbon, if you take calcium carbide will form. This is called calcium carbide. In P-block elements, I am telling different carbide, different alkanes will give. Aluminum carbide, magnesium carbide, propyne it will give. Magnesium carbide, what it will give? Propyne it will give. Calcium carbide and hydrolysis. Here, what is happening? You see. Actually, calcium carbide like this it will exist. Ca plus to C2 minus. How it is forming? You see. Just for understanding, I am telling. So, here calcium carbide OH, H, H. Bond breaking, what will form? Ethylene. Here calcium hydroxide. Understood? Calcium hydroxide to form ethyl. Simple. But how to obtain calcium carbide? Quicklime reacts with carbon. How to obtain calcium oxide quicklime? Limestone heating. Like that. Okay. Next, from vicinal dihalide. This is important. From vicinal dihalide, we can use. From vicinal dihalide, we can use. What they are using, the two reagents they are using. You see here. First, alcoholic KOH. You know, alcoholic KOH elimination. Elimination means one H, one B are removed. It is forming like this. But it is highly stable. The reason is here. You see now here. Here bromine, what is there? Lone pair. Lone pair, single double. Resonance. So this bond is partial double bond character. It is because see now H and P are removed, sir, double bond will form again. We can use alcoholic KOH. No. When I am using alcoholic, only one H are removing alkene. This is called vinyl halide is formed. What is vinyl halide? Very important. CH2 double bonds is attached halogen. This is called vinyl halide. CH2 double bonds is attached halogen called vinyl halide. Or if you take CH2 double bond CH containing CH2Cl now. This is allyl halide. Directly double bond attached carbon containing halogen is called vinyl halide. Directly double bond containing carbon attached carbon containing chlorine is called allyl halide. Important two terms. So vinyl halide, what is happening? Now again we cannot use alcoholic OH because this is not that much strong base. To make strong base, what I am using here? Sodium amide I am using. Sodium amide. It is very strong base to remove vinyl halide also. Then after removing H and we are here another 5 bond. So we are getting finally alkyne. Two steps we are doing from vicinal dihalide. Two steps. Okay. Only two preparations they give an alkyne preparation. Look, only preparations are there. Just only two preparations they given. From calcium carbon hydrolysis we can get ethyl. Any vicinal dihalide, first what you have to alcoholic OH followed by sodium amide. Sodium amide, NaNH2. Then what will form under here? Finally, by the removal of vinyl halide and HBr, another 5 bond is formed. That's it. Two preparations. Next, physical properties. Physical properties of alkane follow the same trend of alkenes and alkenes. Same molecular mass increases, boiling point increases. Branch increases, boiling point increases. First three members are gases. These ethyl, propane, butanes are gases. And next eight are liquids and the higher ones are solid. All alkanes are colorless. Ethyl has a characteristic odor. Other members are odorless. Because more react. Alkanes are weakly polar in nature. They are lighter than water and invisible with water, but soluble in organic solvent like ethers, carbon tetrachlorobenzene. Their melting point, boiling point, and density increases with increasing molar mass. This is same point from beginning onwards. That is only physical property. Next, chemical property. You see here, very important point. Now, how many chemical properties they given? A and B addition reactions they given. All addition reactions and polymerization reactions. Cyclic polymerization. All addition reactions are. Addition here also HOH, dihydrogen, dihalogen, halogen addition, hydrohalogenation, all the things. Same manner. First, you see acidic nature of alkynes. Before that one, this one tell me fast, if you remember. Dilation for what will come? Here H, here OH and here OH, here only OH. Markovika builds blind should not follow here and here. No, here the 5 mother picture OH. Four combination is what means? Right? HCl. HCl peroxide, same. Br2 by CCl4. Br2 by CCl4. HBr peroxide, anti-Markovika group. HBr, same thing, but here we are less. Dilute alkaline KMnO4. Dilute alkaline KMnO4 means what will form? Huh? OH. Here, keto. If you are taking KMnO4 by H plus, then this will be like this only, but this will become CO2H. Simple as R. Correct? Okay. H plus I will explain. See, I am writing here. Magnesium carbide if used. If you use magnesium carbide, what will form? Calcium carbide ethyl will form. That is called acetylene. Magnesium carbide is used, propane will already at the time I said. And see, general dihalide if you use alkalic OH, sodium amide we are getting general dihalide. Vicinal dihalide also if you use same alkalic OH, NaNH2 we are getting. But in oxidation state what is vicinal dihalide? Even general dihalide also like that. Dehydrogenation. But after forming one dehydrogenation, due to resonance, this bond is not easy to break. That is why again alkalicals they are not used. Sodium amide they are used. Strong base. Like this, tell you what is forming. Alkali and NH. Both. What will form? CH3, C, triple bond, C, CH. Like simple. Why? One HCl removed, one HCl removed. One HCl removed one by one, and then HCl removed another by one. Here, same. Then what will form? Tell me. Simple. One HCl removed, one HCl removed. Simple. But you are seeing this is visceral dihalide. You are seeing this alkalic NaNH. Then you have to understand it is the preparation of alkyne. Are you getting or not? Like this, easily you can do. Here what is formed? Same manner will form. It is visceral dihalide, even though no problem. First here HBr, 1 pi bond, other HBr 1 pi bond. So we are getting CH3, C, triple bond, C, single bond, CH3. Here also like that only. Means what will form? C, triple bond, C, CH2, CH. Same there. One HBr removing, other HBr removing. Now OH. Next class I will explain.